this video I'm going to record about regression. It is going to summarize what we did in the first two lectures. It's going to be mainly theoretical. Maybe then I'll record a video of how to do it in practical. So let me just recall the situation. So you have y1 yada yada to yn. This is your y, right? These are observation to your y. And we actually looked on the one-dimensional case where we have only x1 to xn. So we had only x1 to xn, right, in previous semester. And then we decided that we can take y and represent it as alpha plus beta x plus epsilon. And we know that this is a residual. And you know that covariance epsilon of x equals to 0. That was our setup in the previous semester. Now today, right, we want to do something a little bit different. So what we want to do today, we want to actually add more variables. So we have here, this is going to be our first variable. This is going to be our second variable. And we have k variables. So each one of those, right, is a factor. Each one of those, you can think about this y1 as being, let's say, a stock, right? And those are factors. There can be different factors. It can be economic factors. Yeah, it can be inflation, for example, or it can be also some, some stocks. For example, right, recall the classical CAPM, right, that that mu of the stock minus return, right, equals to beta times mu m minus r, where r is your risk-free rate. Now, maybe you're saying, I don't think that it's just a market that is going to be dominant, right, when we're talking about stocks. Maybe there are some other factors. So then you will have a model like that. And then it's going to be factor minus risk-free rate. Okay, plus maybe some intercept alpha. Okay. So we have this situation, and once again, we want to find our betas, right? And now we're going to represent it not like, with one factor, but we're going to say that we're going to have multiple factors. So y, which is this guy, right, is going to be alpha, or let's say that this is beta 0, plus beta 1 times x1 plus beta 2 times x2 plus yada 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 beta n times xn plus epsilon, right? And what you want to know that the covariance of epsilon with all the xi's is 0. That's the first condition. And the second condition, of course, that the epsilon is residual 0. So the averages, right? The average is completely explained by these factors. The only thing which is not explained, right, is an error to these factors. Okay? So on each line, so let's say this is yi here, right? So what you're going to get the following. You're going to get yi equals beta 0 plus beta 1, and then you are going to get xi1 plus beta 2, xi2, yada 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 yada. So this is k, of course, and you forgive me, then beta k xik. So, people like to write it in a matrix form, okay? And then they will basically write that y equals to beta times x plus epsilon, right? Now, this x also includes, right, beta 0. So then it is going to look like, the matrix is going to look like not just this matrix, but it's going to be 1, 1, 1 in the beginning. Then it's going to go x1, 1, yada, 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 until xn 1. Then it's going to go x1, 2, yada, 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 until xn 2. Then it's going to go until x1k, xnk. Okay? So that's, right, the setup for the regression. Now, you need to find the beta i's. So the beta i's can be written in a very neat and compact form. So you can say that your beta, okay, is going to be equal to x transpose x to the inverse times x transpose y. Okay? So let's look on all these guys separately. Let's first look on this guy. So what is this guy? What is X transpose X? How does the matrix X transpose X looks like? Right. So what is this Aij? Well, it's actually easy peasy. You just take the i's column here, multiplied by the j's column here. For example, right? So, you know, the general formula is going to be basically I goes from 1 to n, x, you know, I don't know what we have here, you know, I, j, and then x, let's say this is going to be j, this is k, x, I, k, right? So for example, X transpose X 1, 1 is just going to be the first column times itself. So it's going to be X11 square. Sorry, it's going to be 2, 2, and I'll explain why. X11 square plus X, you know, whatever it is here, you know, 2, 1 square, yada, 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 X and 1 square. Now, why do I put 2, 2 here? Because remember, the first column of this matrix is 1, 1, right? So the first one, X transpose X, 1, 1, is just going to be 1 times 1 plus 1 times 1 plus 1 times 1. So it's just going to be n. So it's going to be the number of your observations, right? Very simple. Okay? So this is this. What is this? What is this X transpose Y? Well, this X transpose Y, you just take the column and you multiply by the Y vector. That's all there is to it. That's all there is to it. There is nothing more, nothing less, right? So you are going to get basically that, you know, the vector here, right, the X transpose Y, let's say i's coordinate, is just going to be, let's say, the first coordinate, right? It's x11 times y1 plus, what do we have here? We have x21 times, you know, y2 plus yada, 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 xn1 times yn, right? So, you know, to picture it is much easier than to write with all this, you know, with all these formulas, right? So we don't have a sign here, okay? So, you create this matrix, then you inverse this matrix, you multiply by X transpose Y, and you will get your beta, okay? Now, is it better or worse to do this multiple regression versus like one step regression, right? It depends on the situation, but you have to remember something. That covariance of xi, xj, right, is not 0. So these guys can be multilinear, right? So you have to be very careful, because if this matrix is not, for example, you know, if this matrix, right, contains two identical factors, it will not be invertible. So you will not be able to create this regression, right? So when you're doing, you know, when you're doing multilinear regressions, you should always be aware, right, that it may actually diminish your results and not actually, increase the expressibility of your results. For example, it may be, right, that here, let's say that, you know, you have a Capet model without this guy, right? You are having some beta 1. Once you add this beta 2, it may actually diminish your results. It's not going to explain better. It can be explained worse because, for example, this factor has nothing to do with, you know, with your stock, okay? And, you know, situations like this are happening left and right in the financial industry. Now, when you take, you know, so when you do those factors, right, the next question that you want to ask yourself, okay, what about the distribution? Of betas. Right. And we are going to do that in our next video. All right? So it was great talking to you, and I'll see you very soon. Thank you, and bye.